Hey, Algebra 2 class. Today we are going to learn how to add and subtract rationals, but you should have a handout that has these warm-up problems on them. So let's go over them very quickly. Okay, number 1, I'm going to factor into x minus 1, x plus 1. The second term, I'm going to factor out a 2, and I'm going to get x minus 1. And then our 2x minus 1, excuse me. And then let's factor the denominators. So this is going to give me 2x minus 1, and then an x minus 1. And then this denominator, I'm going to factor out a 3, and I'm going to get an x plus 6. Okay, so I've taken each one of my terms and I've factored them. And now let's cancel. So any like terms get canceled. So x minus 1 with an x minus 1, a 2x minus 1 with another 2x minus 1. So we're left with x plus 1 in the numerator. And then the coefficient I'm going to bring over is this 2. Don't forget it. And then the denominator is 3 and then x plus 6. So that's how you work the first one. Okay, then the second one, I've got to factor this denominator, and I've got to take a 2x out, and that leaves me with x squared plus 5x minus 24, which then factors into x plus 8, and then x minus 3. And I'm going to bring that down, and then don't forget your 2x also comes down. So right here is what I factored to. And then this x plus 1 is over 1, so it's really on top. So I'm going to cancel the x plus 8 and the x plus 8. And then I'm going to take a 2 out of this 4. I'm going to cancel it with that 2. And then I'm going to take an x out of this one because I'm canceling with that one. So that's just going to leave me with 2x. So what's my final answer? Well, in the numerator, I only have a 2x. And then in the denominator, I have an x minus 3. And there is my final answer. Okay, now let's look at the other two. Okay, these are division problems. So remember, we keep, change, flip. So let's factor the top, an x plus 5 and x minus 2. In the denominator, I have a 3x times an x minus 1. And then over here, once I flip, I have an x minus 1 in the numerator. And then I'm going to factor to x minus 6, x minus 2. Now I can cancel my like terms. So my x minus 2's cancel. My x minus 1's cancel. And I'm left with, I'm going to write it right up here so I have some room for the other problem, x plus 5 over 3x times x minus 6. And that's how you work this one. And then the last one is, let's factor out a 2x squared. And that leaves me with x squared minus 3x, oops, minus 28. And then that is all over x squared times x minus 5. Okay, and then this is going to factor into what multiplies to 28 that has a difference of 3. And that would be, let's see, 28 is 7 and 4, so minus 7, x plus 4, and then times, and this was x minus 7 over 1, so it's 1 over x minus 7, and I can cancel x minus 7's, and then x squareds, and I end up with 2 times x plus 4 in the numerator and x minus 5 in the denominator. And there's the final answer. So there are warm-up questions. Now let's go on to our lesson. Okay, so here's our lesson. We're going to start learning how to add and subtract rational expressions. Okay, a rational expression is just a fraction. So we know fractions, in order to add and subtract, you have to have common denominators. So these first two problems we're going to look at are very easy. They have a common denominator of 5x. And so I'm just going to bring my common denominator over, and I'm going to add my numerators. So I'm going to end up with 10 on the top. So this is going to simplify, because I can take a 5 out of each one of these, right? I can reduce them by 5. I end up with 2 in the numerator and an x in the denominator. And that's what this problem simplifies to. So I'm adding 2 over 5x plus 8 over 5x becomes 10 over 5x, and it simplifies to 2 over x. Now, these are pretty easy when you're adding with common denominators. So now let's look at one that has binomials. So I have a binomial on top, an x plus 3 plus an x minus 2. Notice my numerators match, so I can just bring my denominator, over. It's just going to be an x minus 1, and then I add the numerator. So I'm going to add this to 2x, and I'm going to add 3 and negative 2, which is to positive 1. That one I can't factor, so there is my final answer. You always want to try to factor these because sometimes the factors will cancel. Now, let's try a subtraction. So again, I have common denominators, so all I'm going to do is bring over my x plus 3. Now my numerator, I'm going to subtract. So what is 4x minus x? Well, that becomes a 3x. And there's nothing I can factor, so I'm finished. Okay, now let's look at one that has binomials on top. Now, anytime we have a binomial on top, it's a little trickier because we know we're subtracting the quantity x minus 2. So denominators, easy. We just bring that over, and that's a 2x. Numerator, though, we have to take x plus 3, that quantity, and subtract x minus 2. So we know when we're subtracting a quantity, we have to distribute in the negative. So I'm going to rewrite this without parentheses, x plus 3 minus x plus 2. So those signs are going to change. And that becomes, well, x minus x just cancels out. That's 0. And then I have a 3 plus a 2, and that's a 5. So my numerator is 5. And there is your final answer. Okay, so on to subtractions, just make sure you distribute your negative in. Okay, now let's try a couple of these. You can pause the video here and practice these very quickly. I'm giving you a chance to work these, and then you can check with each other. I'm going to go ahead and start teaching you how to do different denominators. Okay, so find the sum or the difference with different denominators. So this is the harder part for sure. What you have to do is you have to look and figure out what your common denominator is. Well, 5 goes into 15 by a factor of 3. So I have to look at the larger number. So 15 is the coefficient that is my common factor. Okay? And then I've got an x squared and an x cubed, and I always have to take the larger exponent. So my common denominator is going to have to be 15x cubed. Well, I need to go back and look at the 5x squared. What do I need to multiply 5x squared to get 15x cubed? I need to multiply that by a 3x, because that would then give me 15x cubed. Now, if I multiply the bottom of a fraction by some common factor, I have to multiply the top by the same factor. So I've got to multiply the top, or the numerator, by 3x. So 3x times 3, that's going to give me 9x. And then I look at the second fraction. What do I need to multiply 15x cubed by to get 15x cubed? And the answer is nothing. So I'm just going to bring over my x plus 7. Now I can add my numerators together. So that's going to give me 10x plus 7 all over 15x cubed. Now what I need to do at this point is see, does the numerator factor? Can I find a common factor in 10x plus 7? And the answer is no. So I've finished the problem. I can't reduce it at all. Okay, let's try another one. Okay, that's how we handled monomials. So now we got to look at this one. This one has binomials. I have an x plus 2 and an x plus 3. And I like to put my parentheses around these and treat them as one term. Okay, this is one term, an x plus 2. This is a second binomial term, x minus 3. I need to have one of each of these represented in my denominator. So my common denominator is going to be x plus 2 times x plus 3. X minus 3. So then I go back and I ask myself, what do I multiply the x plus 2 by to get this common denominator? And I'm missing an x minus 3. So I can multiply the denominator and the numerator by x minus 3. So now I've got to distribute this in. So that first term is going to become 12x minus 36. Because I had to distribute. Then I'm going to add to it the second term. Well, what's missing in my denominator from the second term? I have an x minus 3 and I'm missing my x plus 2. So I have to multiply this by x plus 2. Well, if I multiply the denominator, I also have to multiply the numerator. So let's multiply the top by that. And again, I distribute. And so I get 4x squared plus 8x. Okay, so I've done the hardest part, which was figure out my common denominator and then multiply the numerators by the missing factor. Now I just have to simplify the top. So let's simplify this numerator. I have a 4x squared, and notice I'm putting it in standard form. I'm going to take my 12 and my 8, and I'm going to add that to 20x minus 36. Now, my denominator, I just bring it down. I keep it factored. Notice I've never FOILed it together. I just keep it all factored. There's no reason to FOIL it because I'm just going to factor it at the end. So now I need to see, does my numerator factor? Well, I can see I have a common factor of 4. So I'm going to take a 4 out. And that leaves me with x squared plus 5x minus 9. Now, does anything multiply to 9 that has a difference of 5? And the answer is no. So this numerator is not going to factor. But I needed to check, because if it did factor, it might have canceled out with one of these factors. Okay, so here's my final answer. Now, one thing I haven't addressed is excluded values. We know that x cannot, or that the denominator of a fraction can never be 0. So we need to go back and look at excluded values. And on this one, my excluded value is 0. X cannot be 0 because if I plug a 0 in, it makes a 0 in my denominator. Let's look at the excluded values on the second problem now. Second problem, what makes this factor x minus 2 0? And the answer to that is positive 2. So x cannot be 2 because that makes a 0. What makes the second factor x plus 3 0? And we know that answer is negative 3. So that means x cannot be negative 3. So those are my two excluded values in this problem, and 0 was my excluded value in that problem. Okay, let's try a couple of these. Now, this one is subtraction. And we talked about this with monomials. When you have subtraction, you're going to have to distribute the negative in, but we're not ready to do it yet. Let's first get a common denominator. Since these are binomials, I'm going to have each one of these binomials represented in my denominator. So I need an x minus 7, and I need an x plus 3. Now, let's go to the first term. What am I missing? I'm missing the x plus 3. So let's multiply the denominator by x plus 3 and the numerator by x plus 3. Now, this one's a little bit different because notice I have a binomial times a binomial. So what do I have to do? I have to FOIL it. So let's FOIL this together, and I get an x squared plus 4x plus 3. Now, on top, I've got subtraction, right? I'm subtracting the second term. Now, what am I missing from the second term? I'm missing an x minus 7. So let's multiply the denominator by x minus 7 and my numerator. Whoa, where did that come from? And my numerator by x minus 7. And I've got to FOIL that together. But when I put it down here, remember, I have to treat this as a quantity. So, because I'm subtracting this full quantity of the product. So let's FOIL it to x squared minus 9x plus 14. Now, once I get to here, you probably know what needs to be done. I need to take this negative, and I have to distribute it in and change the signs on the back term. So, let's bring over the first term. I have an x squared plus 4x plus 3. But the back term becomes minus x squared plus 9x minus 14. And then you just bring your denominator over. I'm not going to rewrite it for now. You know what it is. We've got it, two binomials, okay? Let's simplify the top, the numerator. Let's add our like terms. X squared minus x squared, that's 0, so they just cancel. Then I have 4x plus 9x, that's 13x. And then 3 minus 14, that's negative 11. That is my numerator. Now let's bring our denominator down. It's x minus 7 and an x plus 3. And there's my final answer because we know 13x minus 11 won't factor. Now let's define our two excluded values. What makes the first binomial 0? X is 7. That's my excluded value. That means x cannot be 7. And my second excluded value, what makes that 0? Negative 3. So x cannot be negative 3. And that's how you work these. Okay, let's look at a couple more just practice ones. So you've got an adding. Well, these are addition, so these are a little bit easier. Now, this one's tricky. I have an x minus 3, and this is a 3 minus x. They're actually almost the same, aren't they? What's the difference? I have subtraction in both. They're just in a different order. So I'm going to show you a little trick. What we're going to do is we're going to take this second factor, and we're going to factor out a negative 1. If I factor out a negative 1, that makes my 3 negative and my x positive. So I'm going to write it as x minus 3. Now, what I've done is I've rewritten this problem to now a subtraction problem. So I have a 2 over x minus 3 minus, I'm just bringing this negative up and replacing it here, minus 8 over x minus 3. Now I can very simply subtract. 2 minus 8 is negative 6 over x minus 3. Okay, here's the second one. If you want to pause the video here, you can. If not, we'll just keep going. They look the same. Both are subtraction. 5's in front. Let's factor out a negative 1. That's going to be x minus 5. Once we factored that out, now I'm going to rewrite this. This negative just makes this subtraction. Okay, so that means I've got 3x minus 4x, which we know is negative x, all over the common factor, or the common denominator of x minus 5. And there's our answer. Okay, and that's how you handle those that look like that. They're just the opposite signs. They're inverses of each other, additive inverses. Okay, let's try a couple more of these. These are a little bit more involved. Okay, so what we have to do with these is factor the denominator first. So make yourself a quick little list. Factor the denominator. Factor denominator. That's the bottom. Okay, we're going to do that first, and then we're going to find our common factor. And then find your common denominator. I'm going to abbreviate it CD for common denominator. And then you're going to add or subtract. Okay, so the first term, 3 over x, that denominator x will not factor, so I can just bring it down. But the second term, I can factor an x out of that. So I'm going to write that as x times x minus 6. Okay, and I'm going to bring down my 5. Now, I can find my common denominator. So what do I know my common denominator is? Well, they both have an x, so x is going to be in the denominator. My second factor is x minus 6. So the first fraction is missing this x minus 6. So I need to multiply the first term by x minus 6, the second term by x minus 6. And remember, we need to distribute this in. So, cleaning this up a little bit, my first term becomes 3x minus 18. Plus, now let's look at the second term. I factored, both of these factors are in my denominator, so I don't need to do anything. I don't have to multiply the second term at all. So I'm just going to bring down my plus 5. Now, whoops, let me erase this. Okay, and now I can simplify this by just adding my like terms in my numerator. So I have 3x minus 13 all over my factored denominator, x times x minus 6. Now, the numerator will not factor. 3x minus 13 doesn't factor, so I am finished. Okay, let's try another one like that. Now, this one factors both of these denominators factor. Okay, so let's factor these. I've got an x in my numerator, and my denominator is going to factor into x minus 5, x plus 3. My second denominator is going to factor, I hope you recognize it, x minus 3 times x plus 3. Because that's the difference in t-squares. Now, this one's going to have 3 terms in our denominator, right? Okay, what is common between each one of these denominators? And I hope you see, well, x plus 3 is common. So that's one of my factors in my denominator. Now, the first one contains an x minus 5. Well, I have to have that represented in my denominator. And the second one has an x minus 3. So I have to have that one represented in my denominator. So notice I have 3 binomials in my denominator. So now let's go back and multiply. What is this first fraction first term missing? Well, I have an x minus 3, I have an x plus 3, but I'm missing the x minus 3. So I'm going to multiply the numerator by the missing factor, which I then distribute, and I bring it down. So x squared minus 3x plus, what's my second term missing? Well, I have an x minus 3, x plus 3. I'm missing the x minus 5. So I'm going to multiply this one by x minus 5, distribute, and bring it down. So that's going to give me 3x minus 15. Whew, I'm getting close. Now, let's just simplify. All we do is combine our like terms. Well, notice 3x minus 3x, those cancel. So I'm left with x squared minus 15 in my numerator. My denominator contains all 3 factors, x plus 3, x minus 3, and x minus 5. Now I changed the order of that. You don't have to. You can just keep the same order. The order doesn't matter because it's a product. My numerator will not factor because 15 is not a perfect square. So guess what? I am done. There is my final answer. Now let's go back and talk about undefined denominators. What makes our denominator 0? What are my excluded values? This one, what makes that 0, that 0, that 0? I hope at this point you're able to go, oh, -3, +3, and +5. So x cannot be those values. From this problem, what are my excluded values? X cannot be 0 because, right, I've just got a term factored out and x factored out, and x cannot be +6. So there are those two examples, okay? Now, we're not going to do the word problems for today. You're going to be doing well just to be able to add and subtract these. Now, let's review real quick. Review what we did. Okay, we started off by adding and subtracting with common denominators. They're easy. You just bring your denominator over, you add your numerator, and then once you get to here, you factor any factors that can be factored. Like this one's, you can take a 2 out, so you end up with 2x plus 3. The numerator, the denominator is 2x, and the 2's will cancel. So your answer will just be 2x plus 3 all over just plain old x. And then what's my excluded value? X cannot be 0. Okay, so common denominators, when you have subtraction, remember we have to distribute and change the signs. This one's easy, common denominator, you're just going to change the signs at the back. It gets tougher though when you end up without common denominators. That's when you look, like this is a binomial that we're looking at right here. Find your common common denominator, and then multiply the missing factor times both the numerator and the denominator, and then you just combine the top. Really, you just have to practice, but the steps are this. Let's make a slide of just our steps. Okay, the first thing you want to do is find a common denominator. Then you want to multiply by any missing factors. You got to multiply the top by those factors. And then you simplify the top, which is known as the numerator. And you keep the denominator, right, the bottom, denominator, there we go, bottom, factored the whole time. And then just reduce. Okay, so step 5 is any type of reducing that you can do. So that involves, if it's just canceling a factor, you might have to factor the top, factor the numerator, and cancel any common factors. So there you go. There's just kind of an overview of all the steps. Hopefully you guys can do this, and I will see you tomorrow.